Good morning. Glad that you all could be here. My name is Guy Guillermo with Unistrut, Hawaii. Our topic this morning is the pros and cons of non-penetrating rooftop supports. I want to qualify what we're going to be talking about this morning by saying that non-penetrating rooftop supports are not always the solution for your project or for your site. There's a lot of factors that go into it. There are seismic conditions that have to be met, wind loading conditions that have to be met. Many times non-penetrating rooftop supports will meet these conditions and have met these conditions, but it's really a case-by-case basis, so it's not a one-size-fits-all kind of proposition. And so we want to familiarize then you folks with rooftop supports so that you have just some working knowledge of what this might be. You might have a consultant, maybe a HVAC contractor, maybe you're thinking about renovating your HVAC system, perhaps you're thinking about putting solar or a PV system on your roof, and you have concerns. Some of these decisions aren't made, they're not coordinated to where, okay, well, we're going to put a PV system on our roof right after we re-roof our building. It could be that you just re-roofed your building 2 years ago, you've got several years of warranty left, and someone has decided, let's put a PV system on our roof. And at that point, you don't want to pay the expense of re-roofing your building just to accommodate the PV system. So sometimes these things aren't on schedule. And so maybe the warranty on your roof is not coming up at the same time that the warranty on your HVAC system is coming up. And if that happens to be the case, then you're going to have to renovate without touching the roof, preferably. Okay, so we want to familiarize you with this morning engineered non-penetrating pipe supports, mechanical supports for mechanical equipment, things like pipe crossovers, service catwalks for elevated equipment on your roof, and a host of other different types of roof-mounted services related with mechanical, electrical, or plumbing services. And hopefully you'll be able to have some working knowledge of then the benefits of engineered supports. And we are talking about engineered supports. That means that someone is evaluating and analyzing your specific site, the specific equipment or service that you're wanting to provide to the building, and then we're coming up with a solution. They are coming up with a solution that's going to meet all the codes, all the requirements for your system, in order that eventually what we're trying to do here is maintain the integrity of your roofing system. And that's why non-penetrating rooftop supports, I think, have taken off in the first place, is because over time, it has been the case where roof penetrations will cause problems in the future. And you can understand that as building owners and maintenance people, you understand that a leak in your roof can be very costly. All of a sudden, you have a leak in your roof, you're having to replace ceilings, you're having to replace walls, you're having to replace flooring. You're basically renovating an entire room simply because you've got a hole in your roof. It could have been from construction prior, as opposed to someone actually damaging your roof while performing maintenance operations. And so the less times that you penetrate the roof, the better opportunity you have in keeping your roof membrane intact and working the way that it is intended to work. And of course, the roofing membrane manufacturers you know, they have certain conditions that will apply in order to keep their warranty in effect. And so you want to comply with all those conditions when you are considering mounting rooftop services. So that's what we're really trying to do here is keep the roof membrane intact so that none of the assets inside of the building are exposed to damage, because it's expensive. I recently came across a case where there's about a quarter-sized hole in a EPDM roof membrane, and found out that the going rate to patch that is $1,500 to $2,000, less than a square foot of material. Some guy's going to go up there with some rubber and adhesive and some coating and charge you $1,500 to $2,000. It's expensive. When I heard that, I realized I had made the wrong career decision, because I need to be in the roof repairing business rather than what I'm doing. It's expensive. It's expensive to have someone come out and repair your roof. So you want to make sure that either if it's new construction or a total renovation, or you are just bits and pieces, you are adding things to your roof or changing certain systems, you want to make sure that the first thing that the first consideration is not just the service that you're wanting to provide the building, but that the roof membrane is going to be protected and will keep its integrity once the service is installed and up and running. Okay? If you would, next slide. Okay. Now the thing with non-engineered supports is that if you're up there and you have a contractor that's just guessing, well, this looks like it's sturdy enough, this looks like it will do the job, this looks like this support is adequate, and you are, and he is providing a non-penetrating support. If it's not engineered, you just don't know. The guarantee of having an engineered system is that there is, like I said, you can have someone who's going to actually analyze the conditions, going to analyze what the requirements are for the building in your area. We're going to recognize and consider the codes that are applicable for your building. And then they're going to design something to meet that requirement. That's the advantage of having engineered supports as opposed to, well, we've done this in the past, it's always worked on all the other roofs that we've worked on. We haven't had a problem, so this is how we're going to do it. But you'd have to make sure that, again, you've consulted with the roofing company, the roofing manufacturer, the membrane manufacturer, if that's going to work for them. You know, if something comes up, like an earthquake or a hurricane, is our stuff going to fly off the roof, or is it going to stay in place the way that we want it to? All these things need to be taken into consideration. So engineered supports, I would tell you, would be the way to go, whether or not it's penetrating or non-penetrating. Because if it is penetrating and you are connecting straight to the structural framing, then any forces on that created from that system that transfer to your structural roof framing. I mean, if you have twist and you have deformation of your steel framing that's supporting your roof, you'll eventually have a roof failure. So there's a lot of things to consider when you are going to be supporting MEP services on your roof, and so we feel that engineered systems are the way to go. In many cases, as we see here, non-engineered fabricated supports are fabricated based on immediate need and not long-term consideration. So here is a picture of a typical pipe support that kind of indicates a short-term kind of thought. And this is on a set of drawings. This is which one right here? Okay, thank you. This is a typical detail using wood. Now, you know, if one of the things that you want to consider when you're doing your rooftop supports is will the supports last over time? As you know, lumber will rot on a roof over time. You've probably seen it in certain applications on the buildings that you folks maintain and oversee. And what happens is that your support deteriorates, and then the pipe is not supported, and service is lost. Or we're going to have some damage on the roof. Here's a picture of a support that we're talking about. This is a large pipe, insulated pipe. This is probably at least 6-inch pipe. And as you can see here, we have a welded support. So from a strength standpoint, from a load capacity standpoint, this support is adequate. What may not have been put into consideration when fabricating this support is that that pipe is going to move, or the fluid inside the pipe is going to move. It's going to create a wave, a shock wave in that pipe that's going to cause that pipe to move back and forth. And without any consideration for a moving pipe, what happens is that you get that sled kind of situation with the channel iron here on the bottom, and it starts digging into the roof. Not only is it digging into the roof, but it's also creating a crater here, which will do what? It'll collect water. Now, not only have you put a hole in your roof, but now you've also created a gathering means for the water to be attracted to your hole. And then whoever is underneath this now is calling you, telling you, you need to fix my interior. And so again, we're getting into some costly undertakings here because we didn't properly design or take into consideration all the factors in designing an adequate support for this particular system. So failure then I got to point to you again. Failure to provide adequate details then allows a contractor to basically do what they think is necessary, what has worked in the past, what they've done before. And it may not match the roof structure or the roofing membrane that you have on your building. So we can't leave it up to the contractor to use what has worked in the past in order to provide adequate supports for our building. So weight distribution is a consideration that we need to take into account when we are designing our rooftop supports. The rule of thumb, if there's one thing I want you to leave with today with our discussion, is remember 2 pounds a square foot. If you don't remember anything else that I say today, remember 2 pounds a square foot. That is the rule of thumb that you want to use as to how much force, I'm sorry, not 2 pounds a square foot, 2 pounds a square inch. Erase what I just said from your mind, okay? Take another sip of coffee right now and then 2 pounds a square inch. You do not want to exceed 2 pounds a square inch loading on a non-penetrating roof support. So you can, it's basic math, is it not? You take the surface area of your base, you take the weight of the equipment or the service that is being loaded onto your roof, you make sure then that when you divide that weight into the square inches of your base, that the number cannot come out any more than 2. Very simple. Okay, that does require some research. You have to have somebody tell you how much it's going to weigh, or you're going to want to know how much it weighs. You're going to want to check the plans or the shop drawings, whatever it may be, run a quick calculation just to make sure that they may know what they're doing. But you just want the peace of mind that you've covered it. In case something comes up and somebody asks you, well, didn't you consider the weight that was going on the roof? Well, yeah, I did. I made a calculation. All right? So 2 pounds a square inch. You do not want to exceed that load on top of a roof membrane as a rule of thumb. Okay, so when we when we consider how we're going to design our rooftop supports, we have to take as a factor the weight of the thing that we are supporting. And as we have seen before, improper design can cause damages then to our costly damages then to our roof.
Right, just
yes, sir.
mathematical question here. 2 pounds per square inch is engineering-wise a direct relationship to 120 per square inch per square foot. So you're talking about 288 pounds per square foot.
Just about. Yes.
That's more than slam on the roof.
What's that?
That's more than if you have mezzanine stuff. That's a higher weight ratio.
It could be. It could be. You know, typically, if you have, you're not going to take a roof. Let's say, for instance, you have a building, and there is no roof-supported services. Okay, it's highly unlikely that you would be able to say at a later date, oh, well, we're going to mount all of our HVAC systems on the roof now, instead of on this. Instead of having it either supported by the structure inside. You probably can't do that, simply because the roof wasn't designed for that. An engineer and architect will design, if they understand that if they're gonna design a building and they're gonna mount, and that's been determined that the HVAC system is going to be mounted on the roof, as opposed to having a mechanical room on the first floor or something like that. The roof will be designed for those forces. And so with that taken into consideration, then you know that the roof can support an HVAC system. The issue then, in context of what we're discussing this morning, is whether or not then that a non-penetrating rooftop support is going to be the best option then to meet all of the requirements for that system. So if in the case of when you are calculating for pedestrian traffic, for instance, as opposed to movement of several hundred pounds of fluid on the roof, then it may be the case where a mezzanine might be designed less than a roof structure that is engineered to handle especially a large HVAC system. So it could be. But the manufacturers, the rooftop manufacturers, the people that manufacture roofing systems, they want to see that number at about 2 pounds a square inch, no more than that. Okay. Thank you for the question. So most failures that occur then negatively impact the roof membrane or the insulation below, as we saw in that previous photo of that pipe support that was digging into the roof. There are certain types of criteria that we want to go through when we are going to be selecting pipe supports, weight loads, we mentioned, job site specific conditions. All supports need to be, as we've said, constructed out of material that's going to be able to last on your roof. Is that going to mean hot dip galvanized? Is that going to mean stainless steel? Maybe some other type of non-corrosion type supports like fiberglass or FRP supports? What's that going to be? And it's all going to be site specific to your particular building. Are you in the middle of the island or are you right by the beach? Okay, that's going to be a big determining factor on the type of material you're going to select for your supports. As we mentioned before, wood blocks will deteriorate over time. And unless you want to be up on your roof replacing lumber all the time for your MEP supports, then you're going to want to select something that's a little bit more durable. All supports need to have a proper base in order that they don't fall over, we don't get movement. Again, movement on your roof is not good, because if your supports are creating friction on the roof over time, that's going to be a problem. And so everything has to be taken into consideration: the movement of the pipe, the movement of the equipment, the vibration of the equipment. These all be considered when you're designing supports. There's one thing that we had mentioned: fluid hammer and hydraulic shock. It's a pressure surge that's caused because there is the fluid in the pipe is changing direction, or it is stopped all of a sudden. And what will happen is that then there is this surge, and that energy is moving through that pipe to the support. And if we don't have an adequate support, what will happen is that then we're going to compromise the support, and in doing so, we're going to compromise the roof membrane. Here on this slide, we're showing the 2 pounds per square inch is the recognized max load any roof membrane can handle in regards to rooftop supports. And again, it's a simple mathematical calculation. You just have to understand what your loading is, how much surface area you have on your leg or your support, and make sure that you have enough bases, enough supports in order to divide that load to where we get to that number of 2 pounds per square inch. Again, more examples of inadequate design supports. Now, this is a welded support. You can see that we've also here accounted for movement of the pipe by having these rollers. Remember the first photo, we didn't have any rollers. This photo, we do. So someone went the extra step and said, hey, this pipe is going to move. How are we going to accommodate for that? Well, they accommodated for it. We still have a problem. More than likely what has happened here is that they have not considered the entire weight of this service. There's 3 of these pipes. As you can see, there's 3 yokes here with the roller supports. And so because of that, then we're still running into this problem that this base here, the surface area of this base is not wide enough or big enough to handle the load that's being applied to it. And so you're getting a failure. And with that failure, again, you're getting pooling of water, and it's just starting to drip inside your building. Here's another picture of, oh, thank you. Here's another picture of the exact same kind of, well, it looks like it's on the same roof. The same kind of problem that we're having, in that we don't have enough square inches here to spread out the load of the service that is being supported. So what we need to know is, what is the pipe size that we are mounting? What's the contents of the pipe? How many pipes are we supporting in one support? And then what then needs to be our support spacing based upon the loading that we are putting on the roof. Now, it's not just pipe. This example is pipe, but you could use HVAC systems, you could use an air handler. You could mount your air handler on the roof using a non-penetrating support. There are other pieces of equipment that exhaust fans and so forth, that you can load on your roof, that again, you're going to need to know what the weight is, how many of them do you need to support, and then how can you design an adequate support for all of that different type of service. So when we come to understanding, the footprint of your support base, we have a typical here 2x4, 18-inch. So in this example, you've got 63 inches, square inches of support. It's good for 126 pounds if we use our 2 pound per square inch guideline. Here is a support that has 286 square inches. It's 18 by 16. It is good for 431 pounds. That's a little more than 3 times the capability of this 2x4. So we can see that by increasing the footprint of the base, we have also protected our roof when we're having to support heavier loads. Now we have there's a guide, you can look this up on the internet when you have piping, and what the piping weighs when it's empty and what the piping weighs when it's full of water. And so you can calculate what your support spacing needs to be depending on the number of pipes, the size, having it filled with water. You know what the weights of those are going to be. And then you can calculate what size base am I going to need at what intervals, 5 feet, 6 feet, 10 feet, whatever it might be, and you can make your calculation as to how big this foot has to be in order to accommodate the service that you are providing on that system. So there's 4 different types of supports that we really want to consider when we're talking about MEP. That is piping. In addition to piping, we have equipment, like your HVAC units, exhaust fans, and so forth, vents, and that kind of thing. Then there is your duct work that has to be supported as well. And then once you have all this stuff on your roof, you've got pipes and you have ducts on your roof, you need a safe way for which the maintenance people can get around on your roof to service all this equipment that's on top. So we're going to be looking at those types of services and some considerations for them. So small supports. What you want is, so you see this support right here. A nice firm base. You have a pad underneath the base, which is always recommended by the roof membrane manufacturer. They're always going to require that you have a pad underneath your support base. And so then here you have a wide enough support base. It's wider than the service that's being mounted. And you'll see that there's a piece of strut here with the pipe clamps. This looks very clean. It's very efficient. And you can see that over time, this is going to last a lot longer, better than some of the other supports that we've taken a look at so far. Again, we're trying to make sure that we're maintaining this 2 pounds per square inch maximum put upon this base. And there are manufacturers that will advertise that, well, our base, and we represent companies that do this. They'll represent, well, our base can support 2,500 pounds, and it's a block that's about 5 inches by 11 inches. So that's like 55 square inches on 2,500 pounds. Well, you can tell that that support or that base can handle a lot more than 2 pounds a square inch. You can't just look at the capacity of the base and say, okay, that's the one I want. Because if you load it to maximum, then you're going to destroy your roof. So when we're looking at that, then we're still being contained or being constrained by this 2 pounds per square inch loading factor that we want to maintain. Here's just some other pictures of different types of small pipe supports for both gas and water and so forth. Again, notice this is not an EPDM roof, but again, notice you have the pad underneath the base, and then the base in this instance is providing for movement of the service. Down here you have something that's not elevated, much closer to the roof, and the roller is actually inside here, and so it just depends upon clearance issues, on how and what type of support will be selected by the contractor or by your maintenance people for the pipe support. And here's some examples of things you don't want to see. Okay, I don't know what this is. It looks like an air freshener out of the bathroom. But whatever that is, it's being used to support this pipe. And as you can see, this is either on Mauna Kea or it's not in Hawaii. because of the snow, but that's an inadequate support. This support here, and you can see the rotting that's taking place on this piece of wood. And so you want to eliminate that, because as this thing deteriorates, it's going to create more problems for your roof, and then you might get roof damage. Here, again, this is something that's MacGyvered together just to provide some support. So these are the kind of things that you want to avoid. And here's a support that's inadequate because it's not even touching the pipe that's supposed to be supporting. As you're doing a walkthrough on your property, you want to be looking for stuff like this, and then making the right remedy for it in order to protect your assets. Large supports, it's basically the same. There's nothing different between large pipe and small pipe or conduit. Again, 2 pounds per square inch is what we are trying to achieve. There are bases, you can look on the internet. There are many companies that make bases for non-penetrating supports, ranging up to 19 inches by 23 inches, depending upon how much load is being put on the roof. Spacing should be determined based on load with a maximum spacing of 10 feet on center. Now, large pipe, again, you're a mechanical contractor. The larger the pipe, naturally, the farther the spacing is, because the pipe itself is stronger. A 10-inch pipe, you can support that, and it'll maintain level. It won't deflect too much over a 10-foot span as compared to a 2-inch pipe. But those things don't apply when you're loading your service from the structural steel inside the building. Those kind of parameters don't work on our roof, because again, we're trying to maintain the integrity of the roof membrane. And so maximum spacing should be probably no more than 10 foot on center, even for large pipe that would typically only require spacing maybe 15 feet, 17 feet, maybe up to even 20 feet. With larger systems, you may also need to brace in between the supports. This particular one doesn't show the bracing. I think we'll get to a picture of that a little bit later on. But so you can see here the wide base on the roof here. This is being supported by clevis hangers. You've got 4 pipes, and so your support is then fabricated and spaced. You can see that if we were hanging this pipe in a building, the spacing would be a lot farther than it is here on this roof. But because of the weight and the fact that we're trying to maintain that 2 pounds per square inch loading, the spacing of the supports is a lot closer. Here's more pictures of other supports, and you have a variety of bases and configurations in order to meet the kind of supports that are required for your system. Duct supports, we're going to keep hammering this because that's the message I want you to get. As you leave the room, 2 pounds a square inch. Load transfer should be all there is when you are considering your non-penetrating equipment supports. Some pictures of that. Here we go. We have a picture. Now this does show the bracing. You can see right here, you can see that there's bracing between this vertical and this vertical, because this duct will move and it will cause movement here, and so the braces are added so that this foot doesn't start to crawl. And so that's part of the consideration when you are engineering MEP supports then on your roof. Here's another example. I don't know if anybody's going to have an extensive system on their roof such as this. Do we have any industrial facility people here? Okay, so probably not. This is a pretty extensive mechanical system here, and what you can see that quite a bit of thought has gone into how this whole thing is going to be supported. But this just gives you an idea of some of the factors that you need to consider when you are designing your supports. We mentioned that there are supports for equipment, such as your HVAC units. And so in this picture here, we have several, we have a cluster then of air conditioning units, each being individually supported with the consideration here that we're going to use a base size that is adequate for the weight that is being put upon the roof. Now, once you have all this equipment on your roof, you need to then provide a means by which maintenance workers can go up on top of the roof, maintain the equipment, and at the same time be safe. Okay, on this side here you see a stair assembly that is made of wood. So we know that there's going to be deterioration. This isn't going to last. This is not very durable out in the elements, especially in a place like Hawaii. The wood would deteriorate very quickly. You can also notice that there is no mid-rail. There's no mid-rail here to meet OSHA requirements. So if you've got a working crew, if you have a maintenance crew, or you have an outside contractor that's doing your maintenance work, they are subject to OSHA requirements. And so whatever you have for them for access is going to need to meet OSHA standards. Now this is something here that would meet OSHA standards. You see that there is a mid-rail, there's an upper rail. If we were to take a tape measure to this certain support, it should be that from the working surface or the step, that the mid-rail is 21 inches and max, and then this needs to be 42 inches from the working surface, your top rail. The consideration here also is that we need to maintain our 2 pounds per square inch. We are making some assumptions regarding the weight of the person. Okay? And we deal in averages here. So we'll have enough adequate support to support perhaps maybe 1 or even 2 people on this structure at the same time. In this case, this is a crossover because you have a parapet wall right here. You don't want the employee hopping over the parapet wall because they might fall on the other side and twist his ankle. And then you got a workman's comp claim. Now what? And so these crossovers are built so that we can walk over not only parapet walls, but later on you'll see that we have piping that we're trying to cross over. And so you want an adequate support. It's going to last a long time, that will not stress your roof. So here we have again a case of a wooden structure that will be subject to the elements. Here is a bank. This is probably an HVAC bank or electrical bank, and typical with roof-loaded systems, large roof-loaded systems. The unit is actually elevated off of the roof. You've got structural steel that's penetrating the roof, and there's a I-beam right underneath here and running along the front edge of this that's elevating this thing up to 4 feet. We just did a project with Kaiser on the Waipio Clinic, and all of their HVAC equipment was about 4 foot off the roof, all on top of structural steel. And they had a network of structural steel on the roof inside their enclosure. And so we came in, and because they had safety issues with their maintenance people, they had us come in and design something similar to this, as you see here, framing with grating. And we then built a platform that got them up to the service level so that they could work without having to climb over pipes and climb over structural steel. Makes it easier for them, faster, more efficient, and the chief concern was that it was much safer for them to work on the roof. So here's one that then is field constructed, and then you have one that is engineered. So this would be engineered for all wind loading, seismic. You'll notice that there are braces here underneath, running in both directions, laterally and longitudinally. You have railing. You have a stair that meets run and rise parameters so that you meet OSHA standards for that. And it's also considered for wind loading as well. Some of you might be asking the question, how can something that's not attached to the roof stay on the roof when there's a hurricane at 130 miles per hour? All of this is considered when you are going through the shop drawing or the submittal phase of the project, where the engineer will take all of those factors into consideration, and they will design a system that will be able to meet all those requirements. If not, if all those requirements cannot be met in your particular site, then non-penetrating supports will not qualify, and you'll have to use a different kind of system. Okay? In certain cases where you have limited access, this looks like to be a access panel right here on this roof, and it just happens to be that they have to put a crossover here at this particular point. So instead of using a stair assembly like you have on the other side, because of this condition here, you have to use a ladder. Well, again, the OSHA has certain requirements on how a ladder is to be constructed and how it's to be designed and used. And so in certain cases, ladders might be the better solution rather than a stair assembly. So, engineered systems are meant to provide support for a wide range of services: piping, equipment, ductwork, electrical, plumbing, and also for maintenance workers to access these services for maintenance purposes. One thing that is highly recommended is polycarbonate bases for your supports, as the feet of your supports. They are non-corrosive, they are UV protected, they will give you long service life, and they won't cut into, like steel has the capacity to cut. Polycarbonate bases will not cut like perhaps a steel base would. And so we have to consider the roof membrane, structure, what our wind loading is, our seismic condition, our seismic requirements, and our load that will determine our spacing. All of these need to be considered when designing a non-penetrating rooftop support. Again, 2 pounds a square inch. All right. What is the maximum loading we want on the roof? 2 pounds a square inch. We didn't sound convicted on that. 2 pounds a square inch. Okay. And so that's what we want to carry away. Most roofing systems today carry a 20-year warranty. And to be honest with you, I really don't know what HVAC systems are running. Again, like I said, it may be that your HVAC system and your roofing system are overlapped when it comes to warranty terms. You know, you might have 10 years left on your HVAC system, and your warranty for your roof is coming up. So at that point, you may not want to invest all the money to revamp your HVAC system at the same time you're doing your roofing system. And so if that's the case, if there are budget constraints, then you want to have a cost-effective way to support your HVAC system, despite the fact that you're going to replace your roof. So that might be a time to consider non-penetrating supports to make both the roofing installation less expensive and to create supports that are going to be, in the long run, less expensive. And you want to find somebody, obviously, that can stamp in the state of Hawaii, unless you have a federal facility. Then you don't need the state of Hawaii stamp. You just need a structural engineer stamp for that satisfies that requirement. Okay. That's our presentation. Any questions or any concerns that you might have?
Standard would be higher OSHA or higher?
Okay, in all regulations, the state can select to exceed the federal requirement. OSHA would be a federal requirement. So let's say, for instance, we have job sites now where they tell us, okay, if you're working 6 feet above a platform, you have to have fall protection. That's the OSHA requirement. HIOSH can come in and say, we don't care what level you're working at. If you're above the deck, you have to have fall protection. And they're well within their right to demand that. What they can't do, HIOSH cannot come out and say, well, the federal regulation is 6, but you know what? It's 10 feet for us. So you can work at 10 feet, up to 10 feet without fall protection. Now, they cannot do that. They can only exceed a federal regulation. So in the case of OSHA, if there is a regulation, like for instance, they can come out and say, well, instead of a mid rail at 21 inches and your top rail at 42 inches, we want another rail in between the 21 and the 42. You would have to comply to that because the state, again, they can set something more stringent. They just can't set something more lenient.
That would be the interpretation of the inspector. One might say, okay, you can have this, and somebody else might come with more. It's got to be something else.
I can tell you, because there's a real issue right now, coincidentally, regarding fall protection on a site. And HIOSH wants to enforce a stricter regulation than what OSHA is doing. And it's catching, and they're finding people. And there hasn't been perhaps the best communication as to what the intent of HIOSH is. And so you might spend a lot of money and think that you're compliant. And then somebody comes out and says, this stair structure, it's not right. You're going to have to tear it down and rebuild it to this standard. So investigate. Just ask questions. And whenever you're sitting down with a consultant, ask questions. The same question that you're asking. The consultant might say, well, okay, this here, our shop drive complies with OSHA. Yeah, but does it comply with HIOSH? Oh, I don't know. Let me get back to you on that, right? So asking questions is a good thing. So you want to make sure that if you're ever sitting down in front of someone and they are telling you what they're going to provide, asking questions, then you'll be able to discover if they have considered everything that we talked about today. And that's why we want to familiarize you with non-penetrating support, because we want you to have at least a little bit of knowledge so that when you're being told something, you can verify whether or not these guys are dealing with you on the level, or honestly, or up to standard.
Yeah, but you don't want to get any inspector mad at you. You put them on you all the time.
Oh yeah. Yeah, once you're on the system, you're on the system. You're being watched. So you have to avoid that as much as you can. Any other questions? Yes, sir.
Your rule of thumb, the 2 pounds per square of it wouldn't be like metal.
Yeah, you have to be careful with metal roofing. With metal roofing or standing seam roof or just regular metal roofing, you want to avoid having to place a support in between your framing below. Okay, obviously you're running the potential of damaging your roof if the base itself is unsupported. So 2 pounds a square inch is a general rule of thumb. Like we said, everything is site specific. So there is no one size fits all. There's no one system that fits all in this case. But if you have a qualified project, non-penetrating roof supports is a much less expensive, much less risky way of mounting your service equipment. So everything is site specific. Your building is unique, just like you. Yes, sir.
So the advisory to that is in a retrofit situation, coming in, you should be investigating and determining what line of deck load is already designed into the building.
Yes, sir. Yes, sir.
Because that 2 pounds per square foot just could also overload for design load.
Yes.
Itself.
Yes, it could.
So
That's,
you can't just say absolutely it's 2 pounds per square inch.
that's true.
Where your roof is already designed for 35 pounds per square inch.
That's true. The consideration, again, are what is sacred, I guess, to the industry of people who manufacture these roof supports is the integrity of the roof. And not necessarily assuming that the structure is designed to handle those kind of loads. What we don't want the supports damaging the roof membrane, and then you're having a leak, and you're having a serious problem. So the 2 pounds per square inch would is in consideration of the roofing manufacturers themselves. What is it that overall industry acknowledged standard? What is it that the roof membrane can handle? 2 pounds per square inch. We're assuming everything else beyond that, but you are correct. You know, you're going to want to take you're going to want to have a copy of your as-built drawing on hand so that whoever is designing has access to that information. And anybody who would design without that information, someone has to be checking that box. Right? Now, we do engineering, and a lot of times the terms of the quote will be that we are not responsible for the integrity of the structural framing underneath. That is on somebody else. That's going to be on the architect, or the engineer, or the building owner itself to verify that what we are putting on the roof, because we will communicate how much load we're putting on the roof per square inch, and that it's responsibility of the owner or the architect to determine that, yes, our roof structure, our structural framing system can handle that.